You should be familiar now with this equation, the cardiac dynamics equation, which involves these three components: cardiac output, heart rate, and stroke volume. And basically, stroke volume is very dependent on, or how much blood you can eject per beat is very much dependent on how much blood returns to the heart and fills the heart chambers so that it can be pumped out. So your heart's ability to fill will feed into and contribute to your heart's ability to empty and eject blood. Now, this is important. We've got some other bits of terminology here to get familiar with. EDV, stroke volume we already know, and ESV. And I suspect that the language is familiar to you already. So the first one stands for end diastolic volume. Now, diastole, you should recall from your heart understanding, means during the heart's relaxation phase. So what this translates to mean is, what is the volume of blood in the heart chambers at the end of the relaxation phase? And we should also know from our previous heart stuff, cardiac cycle stuff, is that diastole is when the heart fills. So during this process, the heart is filling with blood, and EDV is the value of how much blood has filled the heart. Stroke volume, we also know, is how much blood is ejected from the ventricles, from the heart, per beat. So the heart fills, the ventricles fill, the ventricles contract, and they eject a certain volume. And typically an average resting volume might be about 70 millilitres. So you then might be able to guess that the total filling minus the blood that's been ejected will leave a certain value. And the ESV is the volume of blood at the end of the systolic phase of the heart. So systole, you should know, is contraction. So when the heart is contracted and pushes out some blood, what we're saying is some blood is left in there. And this ESV is the volume of blood that's left in the heart. Now, your heart can beat more powerfully or less powerfully depending on how it's working, and also how strong you are and how trained your heart is. So your heart might fill, you might do a gentle contraction at rest or low level activity, and a small amount of blood might be ejected, which leaves some there. If you're exercising, your heart would fill with blood. You might contract more powerfully and eject a greater stroke volume, a higher value of stroke volume, which means less would be left in there at the end of it. So those bits of terminology, really important to get your head around. The end of the filling, how much we pump out, and what's left at the end of the pumping out, the contraction. Here's a bit of an example. So your heart ventricles might fill with 115 millilitres. You might eject at rest a stroke volume of 70, and you're left with an ESV of 45 millilitres. Or you might fill the heart with more blood, so you might be better at returning blood into your heart. So you have a higher EDV. You might contract more powerfully, maybe eject 90 millilitres stroke volume, and you're left with 50 millilitres. So these are variables. These are not set, they are variables. How much you fill, how much you eject, and what you're left with. Here's a different sort of diagram to represent that. So if you have a relatively smaller filling, EDV, and a relatively small contraction, you'll have a relatively small stroke volume. If your heart fills with more blood, you can fill it with more blood. You've got better venous return, which we'll look at in a different video, and you have a strong, powerful contraction. Now, these two things are linked, again, which we'll look at in a different video. The filling of your heart and the power of the contraction are very much linked. It's actually called Starling's law of the heart. Then you will eject more blood during that contraction. Basically, your heart, when it's filled with a large volume of blood, the heart walls get stretched, and a response of the heart myocardium, the muscular walls being stretched, a bit like an elastic band, is that they contract much more powerfully, so a stronger contraction. Or like a balloon, you blow it up more, and then when you let it go, it sort of goes off with greater whoosh. So the bigger the stretching, the bigger the filling, the more powerfully the heart myocardium will contract. And therefore, if it's contracting powerfully, it can eject a larger volume of blood, so your stroke volume can be higher. And you'll just notice here that there's always a residual. Your heart never totally empties, a bit like your lungs don't either. So there's always a little bit of residual. So ejection fraction basically is a way of describing what we've just talked through, but as a fraction or as a percentage. So ejection fraction is the percentage of the end diastolic volume that you eject as the stroke volume. How much, what proportion of your filled volume do you actually eject? This might sort of show you a little bit more easily. So this volume represents stroke volume. This is what you eject. This is what you started with, your EDV. This one again will help because it gives us figures. So your stroke volume was 70. You ejected 70 of the 150 you filled your heart with, the EDV, and that equates to 60%. So the ejection fraction is 60%. Obviously, if you ejected more, that would change the percentage, or if you filled more, that would change the percentage. Now you do need to know and be able to write in your exam questions values for heart rate, stroke volume and cardiac output. And it's really important that you don't forget about the units. So heart rate is beats per minute, stroke volume is millilitres and cardiac output is litres per minute. In black what we've got is resting values here, and underneath we've got red values. Now these could be for an elite athlete, and so an average person might have a resting heart rate of about 70 or 72 beats per minute, but an elite athlete might be as low as 30. That's incredibly low, but it has implications of how strong their heart is. At rest, stroke volume is typically for an average person 60 to 80, but an elite athlete might have a larger stroke volume, and we're aiming to achieve this. So this times by this equals this. And you can see they're achieving the same thing, but by ejecting different volumes and therefore having to beat more or less times. Moderate exercise then, as we know, we increase our heart rate, whether we're talking about the untrained or the trained athlete. We know that our stroke volume increases. And, whether again that's the untrained or the trained athlete, and it can go up to eject per minute 10 litres of blood. Maximal exercise, now heart rate has a maximum, and that's dependent on who you are because it's age related, so 220 minus your age. Stroke volume has a maximum. Remember that occurs at about 40 to 60% of your maximum heart rate, so you'll reach your maximum stroke volume well before reaching your maximum heart rate. And it can be 120 if you're untrained, maybe a bit higher if you're highly trained. Again, cardiac outputs can be different depending on who you are and what your maximum heart rate is. So try to appreciate the difference not only between the untrained and the trained athlete, but between rest, moderate and maximal exercise. So I've thrown in an exam question just to illustrate what you might be asked. So the question asks you to define stroke volume and to give resting value for the average adult. So it asks you to give the value, so you must know that, and if you don't put the unit you don't get your mark, so you must have put millilitres. Interestingly here you've got columns which say accept and don't accept. So accept the amount of blood pumped out of the heart per beat or per contraction, but don't accept the amount of blood pumped around the body. So it asks you to specify out of the heart or out of the ventricles, even better. Here again, a second part of the question: describe the changes that take place to stroke volume from rest to maximal exercise levels. So you'll acknowledge that stroke volume increases and more blood is ejected per beat. You'll acknowledge that there's a plateau, and that typically happens maybe 40 to 60% of maximum heart rate. You'll possibly mention that stroke volume can actually decrease a little bit during maximal exercise. So we get the plateau in submaximal exercise, and we get the decrease in maximal exercise, because basically your heart's beating, it explains it down here, why, the explanation. Your heart rate is so high, beating so quickly, that you're reducing the diastole time, reducing the filling time of the heart. And if you can't fill completely, obviously you can't eject as much blood. So the faster your heart rate is, or the faster your heart contracts, the shorter your diastole period is. And here's our value. So maximum stroke volume could be anywhere between 120 and 200 millilitres. Make sure you give that. Lastly then, a graph really just to try to show you the interaction of all three components. So heart rate increases linearly as you work harder. Stroke volume increases quicker but plateaus, 40 to 60% of max heart rate, plateaus and then can decrease if you're working more maximally. And then cardiac output, of course, goes up to its maximum.